Hello to you. I'm so happy to be amongst you. I'm sorry for the delay. Uh, we want to start our session today, and of course, I'm starting the Raspberry Pi Kids. You can see the microcontrollers first, and then from there we can see what to do on the other things. So we will be showing you some rings, and also we'll be working on some sites which are also very important for us in terms of the robotics and artificial intelligence. So without much ado, I'm going to start with the Raspberry Pi kit, which were, and I think you can have a look at them. So this is the box which is holding them, and let me start with before I start with the accessories, let me start with the machine themselves. So you can see this is what they're calling the Raspberry Pi. As you can see, this is a full computer, and I want to show you some parts which you can have a look. So it looks small, like a credit card, but if you see, you can see the ports of which you have here. You can see the HDMI. There's a way to call the HDMI ports here. There's some ports which you can see from now. You can have a look at them. This one, which one connected the monitor, and then this is, of course, you can see the USB ports. This is we have the 3.0 and the 2.0, so you can connect your keyboard and mouse at this point. And this is what we call the RAN, the local area network, where you connect. But the Raspberry Pi also has what we call the Bluetooth and the Wi-Fi. So on its own, you can do the Wi-Fi and Bluetooth. And then you can look at the ports. There's some pins here. These are called the GPO, general purpose pin. There's some pins which you can have a look at them, and just have a look at. You can have a look at this. So this GPO will be working on some of your projects, simple projects. Let's say you are moving, but let's have a good example. Like you want to create a robot which is moving, or maybe a drone, or maybe you want to create an automation system. So this is how the Raspberry Pi looks. And then this being an hardware, just like a computer. Of course, you need a monitor. And we need a monitor when you're connecting. So you can use if I can have a look, can just use this one. So at the look here, you can see the monitor which I'm having here. So this monitor here, you can use this monitor which is at the back of me for you to connect for the display. So for those to be asking, so after connecting all these parts, you can then use, and it uses an operating system called Linux. That's how it is. So I don't know, maybe if you have any questions, you can of course write on the chat, which is there below. So things here. There is it is a normal charger, as you can see. So some of you be asking how it is charges. So you can see this is a charger, the normal charger, and you can see where you are supposed to put your. This is where you connect it. So you can see this is where you connect it, and if I can, because I have with me, I have the extension here, so I can try to power it, and then you can see how it's looking. Let me see if it's possible. Yes, you can see it's on. There's this. Yes, you can see there is the diode. It's on, but I've powered it. It's on. I powered it on, and then, of course, that's how it looks. And then on the same, we have what's called the heatsink. Let me see the heatsink here. So because it can generate a lot of heat, So you can see there's an heatsink here. There's an heatsink which you can plug it, which you can drag it up here. There's an heat sink here. This is the heat sink. So it's put, there's some ports here. There's some holes here, which you can include. And then this is the heat sink. So if it's attached on top, it means that you can work on it for a long time. So if you're having a situation where we're having something like this one, and when it's full like this, so you can have a look. That way, this can help it not to overheat. So that is sometimes what we work on. So after showing this one, so let me go and search on our website now. Because Robotics Society of Kenya, Code Clubs, will be using what we call Raspberry Pi website, which has the resources for kids. And I want to show you just how we go and start the clubs. So without much ado, I'll prefer to share. I'll share the site, and it's going to come from, let me set the screen. Yes, and let me put Chrome tab here. And let's see if we can continue. Okay, before that one, let me put another. That is let me search from the Google search, of course. Let me put what to call Code Club. Code Club. So let me share it from here for the presentation. Yes, that is where we are now. So I hope you are able to see what I'm sharing in. So when you go to search, when you go to Google search here, you create this one, the Code Club. I can even edit it again. You type Code Club like this, and it's just going. It can show you what is coming in. So Code Club. So when I've done this one, I can just press the enter key, or I can search. As you can see the pointer here, I can just put that one, and then there is the drop down menu. And the drop down menu, you can have a look at what we have in here. So what we're interested here is the Code Club, and let's see, we navigate. So there's the options here. You can start your club in your school. You can find, but now what we need here is to use the resources which are on the Code Club, and so we create Code Club, and as you can see, the Code Club is for kids. I can roll the cookies. So you can see the Code Club is around kids, the age of the kids. Actually, it's checking on a global network of free coding clubs for kids 9 to 13 years. And I believe that most of you are watching here right now, be the parents, be the teachers, and others. This is the club, and it's a free resource. You don't pay anything here. So you can try and scroll and see how many clubs are here. So far, we have 13,000. We have countries, and so the kids who have gone there to work. And you can see the free resources. That's what we're talking about. If you can have a look here, you can see. So in the long run, what we're going to see is we're going to have many. We're going to have many. We're going to have many clubs, and then we'll be helping each other. That is what we have. So let's try. If you don't have a club, because you are this, for example, this is United Kingdom. Let me see if you can have any club in Kenya. Let's see if Kenya has any club here. And let's see and search Kenya and see if we can have any club in Kenya. So I think they have not shown, but let's try and see if we can access their the free resources. I think that could be much important thing. So if you don't have one, you don't have to worry. And when we want to work on this, we want to work on very simple. We want to start with Scratch, and then of course we go to HTML, CSS for the creating websites, and then for Scratch is drag and drop. You drag the document, the blocks of the code which are there, and then of course we want to work now on the text one, which is called the Python. So let's see, you can sample some projects here. So you can see the URL here. You can even simply, if you take this one, what I'm pinpointing here, you can simply search this one, and after searching this one here, you can. So let's see the kind of what we have here. So this is what I was saying about. You have three pathways, three categories. You can use what to call Scratch. This is this is the intro. Now this is where you are starting as the first journey, and then you can of course come here to HTML and CSS for creating website. So some of you here, people are talking about what to call a website. You read the newspaper online, and people are talking about that's how you create a website. So this one will allow you to create on your own if you have the internet. Then you have also the Python here. So these are three pathways. We assume that when you are done with this, and first thing starting from scratch here, I think you'll be in a good position. Let me see if I'm still sharing. Yeah, that's awesome. I'm still sharing it. So let's have a look at Scratch. So let me touch Scratch here and see what happens here. And you can see that it can allow you, for example, if you are registered, you can log in and start your project and get new skills. And let's see if you can start any project here. And if you can allow us to start without manners, you signing in. And so it's loading. You can give a. Want to see the interface, how it looks. So this is level 1. And want to see how you can just saying you can create your scene. So let's tap the first one and see what happens. If it can give us the interface. So look at, let's have the extra, have a look at that, how the extra looks. So we have the blocks menu here. This is where we are in, and this is what we see. So in the normal interface, that's how you see how the Scratch will look. So that is the interface. They call it the interface. How you be working your kind of projects in. And I think this is a good sample here. And you won't have to just scroll back and see how the cat will look at, how you add a sprite. And let me see if we can, because you have not logged in. I think that's where the problem is. But if you look at the way it looks, then let's see if we can have another one, which can allow us to at least to have something. So we are saying after having this one here, you can see the blocks, the kind of the block they are using. Let me see. You can have, that's a sample. Let me also can head back again and have a look at another one. Let's try this one. Look at the web, how the web looks. So you can have that, the differences between them. And the good thing about this one is that it allows you to, after saving, you can correct your patch. So I think the first thing will be, you have to log in and then you can request to your parents to allow it, because if you are not over 13 years, you're not supposed to have, you're not 13 years and above. You're not supposed to have over this grade. So let's see what will happen here when you're creating a website. And so let's see, you can have some code. We assume that when you could have done. So let's see when you start your web page, what happens with your web page. And I told you that these are the skills which you need to create. So we already have the end editor for you to work on. So let's have just a look. So you're going to type. This is what you're expecting. You are going to expect to have such kind of this one. Of course, will run about them. The code which you are going to put here, which will allow you to create your website. So this has what we call syntax. Any programming language has what we call syntax, and the languages allows you to create. So you see, for example, this the kind of the word body here and the header, where, for example, what's the name of your website, for example, and the kind of thing. So when you have done something like this, you can expect to come up something like this here. This is what you are seeing. So this one allows you to code here. So you can see this is the project files the one has done. This is where you code, the editor is there, and this is where your output. So this one allows you when you have coded, if you put this code here and you run it. You see there's an icon here for running to make sure. But if there's an error, it will show you. So this is what you expect after getting that one. So there are some rules which, of course, we'll be working on, and this is the end result. You can put sections, you can put facial expressions, you can attach images, it can allow you to put even sound. So the way the normal, so something like this, and you can save your project, of course. And let's see how the Python looks, because actually what we are working here is look at the 3 pathways, how you can work on those 3 pathways and see, because these are free source, and you're going to also get your certificate from. So the idea is when you are finished with the Scratch, you finished the Scratch, and you've gone to HTML. In that stage, depending on the speed which you have, let me see here. Yes. So we had said earlier, you have to start with Scratch, which is that of drag and drop. You drag and drop the commands. And then, of course, there's the HTML here we have seen. Yes. And then, of course, now, this is the Python now. So when you do the Python stuff, this is the text, the textual now. But I know some have even come up with a Python drag and drop, which has some blocks. But let's have a look and see if you can see the arrow word there. Arrow word is a common practice for any computer language. So when you start a program language, you use the word arrow. That allows you to put the arrow word there. So the arrow word would allow you to test the language if it's so each language has a syntax. So this is let me just put this one here. And Python is one of the simplest language. It's like your normal language, English, like. And one of its syntax is you can, I don't know if you can have a look at it. So when you want to use the word arrow, when you use there are things they call functions, and of course, but in this case, for example, the word here, if you look at here from main.py, this Python, the date time is called a function, or the random. But you don't have to worry about those what you are writing in, because what you are working in is this is the first word here, this one here. Of course, import, as they have explained here, the import lines at the start of code tells Python that you're going to use code you didn't write. Yeah. So, for example, you have what you call maths. You want because already what you call talk about Python is called an open source programming languages. So there's some people who have written those functions and Pythons, which are free for you to use. And this is a language which uses a lot of things. But even let's say it's very powerful that if you think you've heard something about called artificial intelligence or robotics or machine learning, this language is used there. But it's so simple, such a way that as even the education part, you can use it. For example, if you want to calculate the area of a rectangle, or you want to do a simple math, even Python can be used as a calculator. You can give it commands and it accepts. So the word here import, as you have been asked here, is a keyword. Is a keyword in Python, and it's telling the Python language that these are right, you didn't write. So the quotes here, you see the word print. Print, it means whatever you want to work, it's be outputted at the screen. So I said earlier, the word arrow language, this word here. Any programming language must start with this. So for testing, so you can see the syntax. So already on the code, you just scratch print, which is of course the reserved word, and then you open the brackets, you put a comment, you put arrow the word. So let's see if the output, which will be the output here. So this is the output here. So the code is here. This is the files which you have done. And you expect when you run, this is what you said. You can, and then there's some keywords like debug. Debugging means what? When you get an error, for example, the word print or the space, you didn't put the space which was between the opening and closing brackets, the braces. So sometimes it allows you to. So debug is a keyword in programming which allows you to know the syntax. If you didn't follow the correct, so if you don't follow the correct language or procedure, it's called debugging. And then of course print. So he said in Python, a variable is used to store values such as text or numbers. Those are numbers which don't change, and the numbers don't change, and variables. Sorry, I was saying that the variables are numbers which change, and particularly on the context, and they can be either text or a number. So variables make it easier for humans to read what code, and you can see examples which are here. So the word, when I was talking about the word variable, it will be changing. And I think up to this one, where you have reached here, we have just given an overview. Of course, our next lesson will be how we're going to tackle. So our next lesson, because you have done the first one, our next running process, or our next objective, running objective. Now take us back again, if I can do a recap of what you have done. I talked about 3 things. I said you go to a Google search, because that's the common one, but I'm not saying that you can only use Google search. If you're on Microsoft, you can use Bing and search engine. There are so many, but because most of us have Android phone, most of our Android phones, most of us we have Chrome. So when you go there, you search. When you have searched, you type the keyword code grab, and then it will show you. When it comes, you look for the project, and this is the project which you'll be working on. So I said, maybe your teacher, your parent, or your guardian will be ready showing you. The 3 of them. So, but this is the part you have to start. And when you have logged in, because I know it's going to prompt you to log in. If you are 13 years and above, you can create an account. You are allowed to have an Gmail account. That is the global standard. But if you don't have 13 years and above, you can ask your parent, your guardian, your teacher, or your volunteer, the one who's running the club, to help you. And should be an adult person whom you know, not anybody. You don't just have to, when you're going to someone to teach you on this code, it should be very safe. So you don't need to go to anywhere which we are not safe. You must be safe. That's the first thing. You must make sure that the person you are with you are safe and you can convert. So it should be an adult who's known, and your parent or guardian should know when you are coming to work on this. It's very mandatory. So the parent can help you, your guardian, the volunteer, or the code club. So the other option is you can create a club, as you can see here. You can start a code club. So these are free resources. And when you are done, you are given your certificate. So you can practice even in your own. You can use even your tablet, if you have your tablet, but the best experience should be on your laptop or should be on your on your computer, the desktop computer. So that is one of the most important things. So I don't know, let me check on the chat and see if there's any question. I said let me start with here. maybe I can, let me see on the comment section here, because already that's where I left it. So let me see if there's any comments so far for the members here. And so I don't see if you have seen any chat coming in, but I can answer them later. So that's what we are saying. These are the three things. So for the kit, I've said these are some of the things you can do. But to be sure, let me put also another site, the two of them, which also you can work on. Because as much we say that you have worked on the coding, and you also introduced the Raspberry Pi. I talked about this one. You remember? So I want to stop sharing this one, so that we can also, yes, I've stopped sharing, and I hope that we'll be getting some questions if they're there. So let me go give you some more sites, more than this one. This will say the Raspberry Pi, this is what we recommend, and there's another one. So let me give another site, the kind of controls you can use. Even you can request your parent also to give you. So let me first of all and type the first one. It's also the same family. It's called Raspberry. This one is called Pico. So let me share the screen again. And so this is it. So you can come here at the Google search, then you type this one. You type, it's already coming in. It's called Pico, and there are a lot of variants. And let's see the search which is coming here. So you can see this. There is a photo here for Pi file. So if you compare this one, the one which I'm holding here, this is 5, and this is 4. So let's have a look at. Let me see. So this is the 4. So let's add and see the cost here. It's not so much expensive. So let's see what we have as a Pico here. Good. So this is it. So this is a microcontroller, as you can see. So this one you can also use it. It's in Kenya, and the good thing is that the one we are using here, the Pico here, the one which you are seeing on the screen, this one you can use it. It's in Kenya, and you can buy it less than 1,000, and you can do with this. You can work. So this is what we call the breadboard, the motherboard, and you can see this is an simple experiment, which of course we'll be working on. So you see the kind of amount it's being used is $4. So in $4 you can create with the current exchange rate, that's 150. That is around 600-700. So less than 1,000, you can get this one. And the good thing is that it's being manufactured in Kenya, and you can work on it. And one of the fine days we'll be working these examples here. That's what I'm talking about, the ports which are here. So these are a form of what? A form of traffic rights, which of course a good example, which we work on the project. So this Pico, there are 3 variants. There's the one which has the AEDA. There's the one which has a Bluetooth and the Wi-Fi. So there are 3 types of Pico. So you can compare with the one which you have in here. So this is a full computer, but this one does not have the one which you are seeing on the board here does not have a processor like this one. So you cannot install an operating system. An operating system is like a foil. Also, the one which is going to allow, for example, if you have a vehicle, you have a driver, you have a vehicle service in a good condition, but if you don't have petrol, it cannot move. So you could assume that the person who is a user and the vehicle, which is of course the hardware. So this part, this one can have, but it does not have what you call the software part of it. But there's a way it's done, such a way that it allows you to connect the laptop, and then that is one example. And I can head back and see if you can have another one. Then there's another one which is of course very famous, called Arduino. So let me because I'm giving examples. Let's see if we can have Arduino here. Yeah, Nano. There's Nano and the Uno. There are two of them which are known. Let's check this one, Uno, which I think is the most popular one. And I know so let's see what Uno has here. But you can see the amount of it. It's not so much expensive. Let's see if we can see from their official stores what they can have. So we want to see types of microcontrollers which are there. And you can see the amounts they are giving here. That's in the dollars, which you can buy. But I want that as if it's possible. We have an overview. So we don't need to buy it now. What you want to see is the interface, how it looks. So this is what you can work also on your project. So maybe try and compare with this one, and then ask yourself what will be major difference, because it also can do work the same. Sometimes can work the same project which the Raspberry Pi are working on, but and it's also open source. So that's one of the example of Arduino. Let's head back and see another microcontroller also. Let's use we type in what we call a microbit. Yeah, you can put some colon here and research. So we'll also be working on this one, on the microbit. So let's see how the micro looks. So I can see one here is around 6,000. Let's see if you can have from the foundation itself. So you can do a lot of projects also on with the microbit, and it's here on the screen. You can see the interface. There's a lot of projects also, even if you're a teacher, and you can see what the students are having here. So these are some of the kind of the projects which you can work on. There's this microbit, which of course, and there's some also what you call some of the programs which they run. Actually, don't call them competition, call them challenges. And you can see that with this one, it can allow you also to run what you call Scratch. You can do Scratch with the microbit. That one also work. Now that one makes more easier, because that's what we call physical computing. We want to see a situation where, and you can see what they are said, is a tiny circuit board sent to help kids run to code and create with technology, including a red display. You can see this red emitting out. There are some of the things we can be also working on with the microbit here. And then let's talk about the Rust controller. I think this was for the kids. Let's talk on the Rust controller. That is, of course, the Rego. Let's see which Rego. There are a lot of Rego, but it's the one which is most Mindstorms. Let's see, yeah, I can see Mindstorms here. F3. The company they say that they are not manufacturing it anymore, but we don't know. But let's see. And if we have a look at this, This is for Amazon. Let me see if you can have itself from the company itself.
So put the car banner here.
So we can continue from this one here. If we look at the Rego Mindstorms. Let me see.
No, we say that you can get us 2 bundles, remember? We are going to try. One is guaranteed there.
So you can see the photo here for a Rego Mindstorm, but there are so many different types of which cannot. But this is one of the most popular one, which can allow you even to create a robot. So this is one of the most popular examples which kids can use, and I think with this we can be in a position to stop on the microcontrollers, and after getting the microcontrollers now, I think unless there's any question, maybe we are talking. I hope the kids are on, and maybe we can. Because we are talked about also, we were going to talk about a bit of chess, and after that, from there maybe we can play some video. Then we go to the other level of AI because of the what we have shown here. So I think from here I can just give I have a board with me. We can just give a glimpse of how the chessboard looks, the about of some pieces here, and then of course we went to the other section, which of course how to use the generative AI and other stuff like that. So without much ado, let me start with the board here. So with me, of course, I have have a board with me here.
Yeah, same with this. Actually, we
You can
love
see
all the templates right here.
how the chatbot looks at. And of course, we want to use one of the YouTube videos here to at least to have a look at how the board looks, but I have some pieces here. As you can see, this piece here, this piece they call it a king, and you can also have there's another piece here called a queen, and then
Yeah, so where will you guys sit?
then from here we have also some pieces here. There's another one also called, but I'm not going to talk about the movements also because I'm going to give a video here on that you can see. So I just giving them names so you can see. So this is called a Pico, and I'm giving just at random. This is a pawn, a small space. I'm not giving them even the code, but what I'm going to do is that I'm going to give a brief video from YouTube, which is going to describe on how because the web opens, and then let me see the pieces which I have not given out. Then you have also they call it the knight here. So there's a knight here. I know sometimes kids love calling it. So on this, what I shall do, I'm going to share. So I'm going to share a link, YouTube link for you to see basics of how you can do and practice test, and then from there when it ends, we move to another part, of course, of generative AI. So I want to just give an overview of that. So I'm going to share the YouTube video for you to watch on the basic setup and how the pieces move. And when it ends, we'll move to another part. So you will allow me to share my screen again, and then have a So this is going to be around 20 minutes. So you can have a look at that, and then we can come later. So it's starting.
If you believe in yourself and you watch this video 10 times. The game of chess has 6 different kinds of pieces. It's played on 64 squares. We're going to go one at a time. We can't make you Picasso until we make you a finger painter. Let's clear the board. This first piece is the rook. The rook can travel up. He can go down, left and right. Very simple. The rook moves in any straight line. The rook captures by simply running into a piece. So if we put this enemy pawn on g5, notice we say the letter and then the number, the rook can simply slide over, land on top of the pawn, take it off the board. Can the rook capture this enemy pawn? Of course not, but in 2 moves it can. The rook can travel up to g7, and then on the next turn, if the pawn is silly and just sitting there, what are you doing, pawn? The rook can capture. You could, of course, also go to the left, and on the next turn, travel up to capture the pawn. Let's learn the next piece. This one is called the bishop. The bishop moves along the diagonals of the board. Much like the rook, it could travel just one square if it feels like it, or it could go to some sort of in-between amount, or all the way to the edge of the chessboard. If we draw arrows to every single square the bishop can move to along the diagonals, you're going to count, if you do it carefully, 13 squares. I hope you're not afraid of that number. The bishop has all of those options. Notice, if the bishop is on a dark square, it must stay on the dark squares for the rest of the game. The blue square, e5, if it travels, it's on a blue square, another blue square. If the bishop wants to capture something, it simply runs into it a lot like the rook. So, if the bishop wants to capture this pawn, the bishop runs into it and takes it off the board. One funny thing, if this pawn was on a light square, the bishop could never capture it. It has the cloak of invisibility. The bishop could travel here, here, and then here, and all the while the pawn is teasing the bishop. Let's move on and learn the next piece. What
exactly is the sandbox then? It's a 3D method. The building blocks are voxels, which are like...
The queen, she's quite simple but powerful. If you could somehow melt a rook and a bishop together, well, your alchemy would produce a queen. The queen has the power of the rook and the bishop combined. So that means she can go up and down like a rook, left and right like a rook, and of course diagonal like a bishop, and she makes a very pretty snowflake on the chessboard if you happen to be a 5-year-old and thinking in terms of those shapes. The queen can travel to every one of those squares. There's actually 27 of them. And much like the rook or the bishop, she simply captures by running into a piece. Now, if I have a pawn over here on this square, the queen would have many ways to get there in 2 moves. She could go sideways, and then down, she could go diagonal, and then up. She could even go a little crazy and go diagonal the opposite way, and then sideways to capture. I have not named all of them. If you want to try to find a few more on your own, well, go for it. But I'm going to move on and teach you the 4th piece. This old guy here, that's the king. He's kind of like your grandpa. He can still get around, but he doesn't travel very quickly. The king moves one square in any direction. That means up, or down, or left, or right, or diagonal, but again, only one square. He's got a little bit of a force field around him, but that is it. Now, the king has a special importance, which we will get to later, but just to show you how slow the king is, if we put the king down here on the first rank, that's what we call our side-to-side rows, and we put a queen right beside the king, and we have a race to the other side of the board, well, it's not going to turn out like the tortoise and the hare. The king would travel one square, and then if it was the queen's turn, the queen could get there all in one turn. You can see it's going to take the king 7 different turns to get all the way to the other side. He's actually not a very powerful piece. We have 2 pieces remaining. The little guy, we've already named him. He's called the pawn, and you get more pawns than any other chess piece. He's little, but he's important. The pawn can only travel 1 square forward to the square e6. And on the next turn, e7. Now, the pawn does have some very special exceptions. all of the pawns for white will begin on rank number 2. I'm not going to add all of them there. I'm just going to add 4 of them to save time because we're trying to get all this game of chess learned in 15 minutes. So, if a pawn is on the starting row, which for white is the second rank, it has the option of going 1 square forward or 2 squares forward. However, after you leave the home base, you can only go 1 square for the rest of the game. So this pawn on e2, it could go to e3 or e4. On the next turn, it has to go to e5, 1 square for the rest of the game. However, if white wanted to move the pawn on d2, that pawn would have the option of 1 or 2 because it's on home base. Pawns are also the only piece in chess that capture a different way than they move. Let's add some black pawns to make this game a little bit more interesting. And if white just moved the pawn from e2 to e4, it would be black's turn. Black might do the symmetrical move, pawn on e7 to e5. Now this white pawn is actually stuck. It's not because you did anything wrong. Pawns get stuck all the time. Pawns do not capture straightforward. They have to wait until there's another piece diagonally 1 square away. Of course, there's nothing on those squares, and you can't capture a bunch of blank air. However, later in the game, let's just say white moves this pawn 1 square, and black decides to move this pawn 2 squares. Well, that would be a mistake for black. Now, white pawn can capture by going 1 square diagonal and overtaking the square the black pawn is on. And if black is having a particularly bad day and pushes this pawn 1 square forward, white could, of course, capture again. Pawns move forward, but they capture diagonal. A couple more special moves about the pawn that we will learn a little bit later on. We've got one final piece, though, before we can put them all on the board and learn where they start. This last piece is the knight. Don't call it a horse. It hurts my ears when you say that. The knight moves 1, 2, stops, makes a turn, and moves 1 more. And if we were to fill in these squares with red boxes, you would see the shape of the capital L. So many people say the knight moves in the shape of an L. But the knight doesn't just have the ability to move to this square. It could also move 1, 2, turn, and make a backward L. That's another option. Okay, let's add a few more. We've already set F3 and D3. The knight could also move up 2 and over 1, up 2 and over 1 the other way. The knight could also move sideways and then up, sideways and then down, always moving 1, 2 turn. And you can probably figure out the completion of this pattern. Drum roll, please. I don't know if we got a drum roll, but knight can go to c4. Those are the 8 different squares the knight can move to. Now, one trick about the knight, unlike the bishop, the knight always changes colors. The knight's on a blue square, we call it a dark square. If it moves 1, 2, turn, it's on a light square. 1, 2, turn, a dark square. 1, 2, turn, a light square. And if you don't believe me, well, keep moving the knight and eventually you'll get it. The knight has a special power that no other piece has. The knight can jump over things. It only captures when it lands on something. If I put a black pawn on f6, the knight could jump over that pawn just like it's not even there. 1, 2, turn, and it completely ignores the pawn. Now, if the black pawn moves forward 1 square, the knight could move 1, 2, turn, and because it landed on the pawn, that's how the knight captures. The knight can jump over anything, its own pieces, the enemy pieces, kings, rooks, bishops, other knights, but it can only capture pieces that it lands on. Now that we know how all the pieces move, we've got to figure out what's the goal of this game. The goal of this game is actually to put the enemy king in danger so he can't get out of danger. Let's go ahead and learn a couple new words. If it's white's move here, white can move the rook sideways and stop on c5. And everybody watching the video can see the rook is aiming at the king. When the king's in danger, we call it check. Now the word checkmate sounds similar, but that's a special kind of check. We'll get to that in a minute. When the king is in danger, when you're in check, you have to get out of check on the very next turn. You don't have a choice. There are 3 ways to get out of check, and I like to use the term CPR. No, we're not saving anybody's life today. We're just saving the king's life. C stands for capture. If you capture the piece that's putting you in check, obviously your king will be safe. You've removed the danger. In this position, that's clearly the best move. The bishop can move diagonal, land on top of the rook, and when the rook's gone, the black king is not in check. In fact, you're probably figuring out right now, it's actually the white king that would be in check. Let's go back, though, and take a look at another option for black. Rook comes over to c5. The P in CPR stands for protect. That means to put a piece in the way or to block. In this position, the knight can come to the king's rescue by moving 1, 2, turn, and the king is safe because rooks don't jump over pieces, so the knight is the bodyguard. And the final way to get the king out of danger is to run away. That's the R in CPR. The king can run to the left or to the right or even diagonal. All of those would be safe from the white rook, but notice he could not move down the board. If he moves down, he would still be in danger. Now, strangely enough, if he does move down, you're not allowed to capture the king. You have to tell your opponent to take the move back and make a different move. Luckily on Chess Kid, the computer won't even let you make this move because it is considered illegal. Okay, so the king would move back and black has to find a different move. Now, what happens if you're in a chess position where you're in check, but you can't get out of danger? Well, that's when we have to learn a new word. Here, after a small reshuffling of pieces, let's have white move the queen diagonal all the way to the square c7. The king is clearly in danger. He has to use CPR. Now, C stands for capture. Notice here the king actually can't capture, because if he does, he'll be in danger with the rook, and it doesn't do you any good to get out of danger from one piece if you're still in danger from another piece. Pawns don't capture sideways. Knights don't go one square and then stop. I don't know who taught you that. And the bishop can't help because the bishop would need 2 moves to capture, and you have to get out of check on your next move. You also can't protect because that means to block, and there's simply no square in between the queen and the king. C7.5 doesn't exist. And the king can also not run away because if he tries to go left, right, or diagonal, the queen attacks all of those squares. This is actually the most common type of checkmate in chess. It's called queen and helper. The queen is doing the checking, and the rook is the helper. This is checkmate. White wins. Notice white never actually captures the king. He just puts the king in danger, so the king can't use CPR to get safe. But wait just a second, we're not quite done. There's one more way a game of chess can end. It's not very common, and it usually means somebody made a mistake. Taking a look at our chessboard here, let's pretend it's black's move. Black's king is not in check because queens don't move like knights. They don't go 1, 2, and then turn. However, if the king tries to move to any of these squares, he would be in danger, and that's against the rules. You can't put your own king in danger. So what else does black do? If his king can't move, he's not in check, though. He's got this pawn, but this pawn's stuck. Remember, pawns don't capture straight forward. So black has no legal move, but he's not in check. We call this stalemate. Surprisingly, the game ends in a tie, even though white has an extra queen. Much like life, when we use the word stalemate, it means nothing's happening. And here, black can't do anything. The game ends in a tie. So if you're the side with more pieces, you want to avoid a stalemate and go for a checkmate. You've now learned all the pieces. You've learned how a game of chess can end. There's 3 special rules you have to learn, and then you'll be a full-fledged chess player. One is called castling. That's a special move where you get to move 2 pieces at the same time. Usually the battle at the beginning of the game is in the center, so you don't want your king, which is kind of like your general, to be in the middle of the battle. So, castling is between a king and a rook. It's when nothing is in between your king and your rook. Your king travels 2 squares, which normally is not allowed, stops, and then the rook jumps over the king. Rooks clearly don't usually jump over things, but it's all one special move, and the goal of castling is to get your king behind a wall of pawns, which white has just done. Now, black can also castle with his rook by moving the king 1, 2, and the rook jumps over. Kings always move 2 squares. I know the black king's a little further from the corner than the white king, but that's just the nature of castling on the other side of the chessboard. Now, if we put the black king and rook back, we put the white king and rook back, there's a couple times in chess where you're not allowed to castle. If you've ever moved your king in a chess game, you can't castle for the rest of the game, even if you go back to the starting square. If you move your rook, you can't castle with that rook, but you could castle with the other rook if you still had it available. You also can't castle if it has anything to do with check. So if it's black's turn and black moves the bishop to b4 and puts the white king in check, you're not allowed to castle. If we magically sprinkle some fairy dust and make this bishop a light squared bishop, white also cannot castle here because his king is traveling through a square that's under its attack. That's called castling through check. That's not allowed. Luckily, on chess.game, the computer won't even let you do it. And lastly, you can't castle if your king lands in check, but that's always the case. You can never put your own king in check. So if we move this f-pawn forward and we sprinkle some more fairy dust and make this bishop back to a dark-squared bishop, here, white can't castle because if he moves his king 2 squares, he would already be in check by the bishop. So if you're thinking of castling and it has anything to do with check, you're not going to be allowed to. Let's learn a couple of special pawn moves. As you know, pawns are the only piece in chess that do not go backward. So, if white's pawn on h2 moves 2 squares, and then later on moves again, and again, and again, we're not being very fair to black by not giving him any moves, but eventually the white pawn will get to the other side of the chessboard, and you can see what your 4 options are. Instead of just sitting there like a rock, who wants to play with a rock? We allow the pawn to turn into something bigger. We call this promotion. It doesn't matter if you are talking about a job or you're great in school. Promotions are always a good thing. And 99% of the time, you're going to want a queen. In fact, if you already have a queen, you're allowed to get a second queen, third queen, fourth queen. Some people don't know that, but I'm here to tell you that's the rule. So you always want a queen pretty much. We often call this queening a pawn because getting a queen is so common. And so that pawn turns into a queen. The queen is immediately checking the king. And if the king moves, by the way, you could actually keep going and capture the rook. That would be a great tactic, as we say in chess. One more special move to learn. In this position, the black pawn on g7 could go 2 squares to g5 and pass right by the white pawn. Now, this was actually a rule change in chess about 400 years ago. I don't know if you were around for it. I'm guessing not. Pawns used to be able to only move 1 square even on their first move, which means they would always give the enemy pawn 1 chance to capture. But because of this new rule that you know, pawns can move 2 squares on their first turn, we have a very special situation. If your pawn moves 2 squares and ends up directly beside an enemy pawn, and the enemy pawn could have captured if you had moved 1 square, then there's a special rule called en passant, which is French for in passing. The white pawn can go diagonal to a blank square and lift the black pawn off the board to make a capture. It looks incredibly strange. Most people that have not been trained don't even know this rule, but it is a rule of chess. It's only with pawns, and it's only on the very next turn. If you want to capture en passant, you have to do it right away. Let's go back and look at it one more time. Black's pawn moves 2 squares, and he's not directly in front of a white pawn. He's directly beside a white pawn. If I was the white player, I would ask myself, could I have captured this pawn if it had moved 1 square? Of course, the answer is yes. So capturing en passant is also yes. If it had moved 1 square, you could have captured. And because it moved 2 squares, you can still capture, and it's actually the exact same final position. Very strange rule, but it is a rule of chess. Now you know how all the pieces move. Check, checkmate, stalemate, castling, promotion, en passant. See, you're a chess player, you didn't even know it. However, in order to close out our video, maybe let's spend 30 seconds talking about where the pieces start and how to open a chess game. If you don't survive the opening, none of the other things are going to matter. This is where all the pieces begin. Notice the white queen starts on a white square, the black queen on a dark square. If you get that right, pretty much everything else falls into place. And these are my 3 main tips for starting a chess game. Number 1, you want to aim at the center of the chessboard. These are our 4 center squares. So the most common opening moves are e4 and d4, one of those 2 center pawns. And let's go ahead and keep on being unfair to black and give white more moves. If white could get both pawns in the center, that would be fantastic. Next rule of the opening is to get your knights and bishops off the back row. And where should they come? Toward the center. Notice those knights are aiming at center squares. Let's have white move the bishops out, aiming at the center. And then the final rule, besides controlling the center and getting your knights and bishops out, call that developing, is to castle. Get your king safe. Usually that means castling. Here, the king can move 2, the rook can jump over, and the king is behind a wall of pawns. If you can think of those 3 things in your first 10 moves, you will have a great start to your chess game and to your chess career. Congratulations, you did it. You are now officially a chess player, and I look forward to you playing lots of games on Chess Kid very soon.
Well, thank you so much for the session which you had for chess. And of course, I'm happy from the comment section. I'm seeing there's that connection between the question of what's the relation between a robot and coding. So we, of course, we bring also the element of the way Mr. Bernard Wanjara has asked the question. So there is also the question of what is a code, what's a program, because there's programming also, and there's also the issue of robotics. So when you talk about coding, coding is a language. It's like now how you communicate with maybe at home, your own language. So in other words, they call it a set of instructions. Set of instructions means the rules. So like, let's just put the way the language you use, your native language, where you are. Let's say talk about Swahili language. There's that structure. So for a computer to work, it needs what we call instructions, and the instructions are what we call the code. But now the code is let's put the code. For example, if you write one sentence full, our whole sentence is what we call a program. But if you say I'm coming home, let's say for example you say I am coming, or you say today I am attending a computer lesson. That is the full. So that is those are a set of instructions you are asking of. So let's take a good example. If you use the word I am, for example, or let's say you move. Say you are where you are currently. It can be a chess club, can be a computer lab. If you put your table and say I want to move this table 3 steps, you hold the table and then move 3 steps, and you say let me move these 3 steps forward. You count the number of steps you're moving. So you hold the table or the chair you are holding, and they say I hold the chair, then walk 3 steps, and then I turn left. So those are the instructions. And then one turn left, and then right, and then come back where you are sitting. So those are the instructions. Those are the kind of instructions I was saying. Those are the code. The word move, 3 steps, and turn right or left, or maybe say jump. When you reach that 3 steps, then you can say, let me jump. Those are what we call the code. So if you add all this coded, then it means there'll be, so there is program and there is code. Where we say program is a set of instructions. Now, we want to talk about a robot. A robot, let's visualize. A robot can be something which is mechanical, you can touch. But in this context, we are talking about a robot which is going to be an intelligent robot. For example, there's something they call a Venn diagram. If you draw a circle, let me just introduce this word AI is artificial intelligence, which is something like a software. Let's just put it that way. So if you put that AI, which is of course something which imitates a human intelligence for you to think, and then now you put a robot which is something movable, but it does not have intelligence. So when you connect, you have an intelligent robot, what's it called humanoid. So the approach is this: the issue is why we are connecting a robot and the coding is the issue of called physical computing. That's what we're interested in. So I would put that link there for physical computing to give the rationale why we are using physical computing. So for example, is this: if you are creating a robot, you can run many skills. You can run because you're using something like resistors. You can do some sheltering. You can use ICs. So when you have done, let's say you start creating a robot from the scratch. At the end of the activity or the practice or the project, you would have done a bit of electronics. You would have done a bit of programming or coding, and that element of electronics, programming, coding, and all those instructions. Rather than because you remember when we visited the first site of the code club, we said you can code using Scratch. That's drag and drop. And they said from there you graduate to HTML, CSS for creating websites. And then later now, you will also move again and work on what we call the Python, which is text. Now you have to type the text itself. So all those languages, you can, for example, the Scratch and the Python, they can be fed to a robot. And what is a robot? A good example of a robot is the traffic lights. I know where all of you where you are, you have gone to town, end of your city. Okay, let's say even in town. Those where you are seeing people standing, the vehicle standing, and there's those lights, the blue, right? That is a good example of what? Of a simple robot. So, but how, when you put those lights, how those lights come in? Because they don't come there, it's not magic. Those lights don't come in on their own. There are something called diodes. I know those who do physics and other things, they will learn something called a diode, or a diode, something like when you're using your remote control at home. So, for one to have a traffic light, you have to program it so that it can give right when you have to stop, red, green when to go, amber to stop, such kind of thing. So take a good example of an automatic. Then there's another one. In the bank, there's an ATM machine. When you go and plug in your ATM card, how does the ATM know that this is the money I'm going to give? That is a fiscal thing. It's a fiscal. So what we are saying is, for an automatic teller machine, which is an ATM, to give you money, it must be instructed by a program or a code. So a code is one sentence. When you add many of them, they come up with a program, which is a set of instructions. So for a good student or a good learner, it's good for you if you had possible, because of you cannot come and have a project of an ATM, because it's that sensitive, money is involved. So you cannot automate an ATM, but you can use something very simple. You can create a simple traffic light. A simple traffic light is possible. You can use even Scratch. I remember I showed you this. With this one, you can create a traffic light. You can use this one. So by this one, this is a computer. I remember I told you that is a computer. With this one, you can create a robot. Not only a robot, you can also create a traffic light using Scratch. I showed you the Raspberry Pi Pico. You can also do the same. I asked you the Arduino. You can also do the same with the Arduino. And I also showed you the BBC microbit. All those, you can use any of them, you can work on them. And they are interpretable, because Scratch, you can use good one. Scratch can work here. Python can also be on this microcontroller. So we will see which is the cheapest one for us. Which is the cheapest one for us to connect on that one. So why we are saying that we want students to do coding and robotics at the same time is to get that experience. And when students run better by touch and feel physical components, rather than when you have a situation where you're just coding using your laptop. That's the approach. But we're not saying that you cannot code direct. We are saying for you to get better experience, for you to be a good student of STEM and get hands-on experience. So you work on physical devices like this one. You connect it with yourself. This is the GPU ports you can see here. We'll be working on our next project. You can try and do a demo on something which is working for us. And I think that's one. So I'm going to share a link there, maybe to show the physical computing and why we do robots and coding. I will share the links here on the comment section. So I have 2 more sessions. I want to do what we call generative AI, and I want to work on Bard and Chat, those 2 of them. From there, then I think we can wrap up if there's anything. So we are running 2 events. Let me try and, I know some of you, I'm assuming some of you are over 18 years, 13 and above. And we also can target kids from 6 to 9. But we're also saying you can have kids working from 13 and above. They're the one who are supposed to allowed to have an email address. This is the age which is students who are allowed to work on what we call ChatGPT, which is a generative AI. We want to see the interface, how you can ask it, you can query it. You can even ask, it's a very good thing, ChatGPT can also be called what? A robot, because it's a pod, it's called a pod. So sometimes we call it, also there's a debate. People say that it's not, some say that it's not a robot, some say it's a robot. But they call it a chatbot, so it's a pod. You chat, so we want to start with Bard, and then we go the other side. So as usual, you have to go to search. That's what we agreed. When you go to search, it's everything for us, and then you search. Yes, I'm seeing that part. I'm sharing my screen now. And you allow me to share my screen. Yes, when you add here, let it load. You have to add to search, and yeah, that is so good that I can see it. So here on your Google search, you type chat. Already is bring for you, or you can call it even bad. It's no problem. It just gives you the keyword. So it's giving bad log. I can log in. I have this option of logging it. So let me log. Let me take this one. Log in. This is the options. I can sign in. Let me see if I'm like following it. Fantastic. Yes. Now let me sign in. Okay. This is the first one. So this is a Google Bard experiment from Google, equivalent of it's loading, is equivalent of ChatGPT. And now, I think the first thing we want to ask it is to prompt it, because this is what we call the prompt. You can see the interface. And this is one helps you to communicate like the way you are talking with a human being. That's the good thing about it. It gives you the correct information, and we want to use it to answer the first question the same way the way Mr. Bernard Wanjara framed it. He asked what's the relation between coding and robotics. So let's just put the same word the way it's. So we can tell it, for example, we can request it. Tell it that give a relationship, or say like this, teach a 10-year-old kid the difference between, or not the difference, the relationship between coding and robotics. So you have told it to teach a 10-year kid the relation between coding and robotics in what? In can even go further and tell it in how many words? In 100 words. Yes, this is the prompt. This is the prompt you have asked it to teach, to give an explanation. What is the relationship between coding and robotics to a young old kid? So that is what we have. Now, let me see here. You see, it gives me even the option of using microphone, but I've not used it. So I am just going I can press the enter key, or I just click submit. So let me see what it gives us. It will be on the screen. So let's see what it can tell us. Because we are told that to give us, and I'm going to copy it and paste the link. So this is what it's asking us. So it's saying, imagine you have a robot friend named Robbie. Robbie is like a computer. But instead of sitting on a desk, Robbie can move around and interact with the world. To tell Robbie what to do, you need to give him instructions in a language he understands. The language is called coding. Coding is like writing a recipe for Robbie to follow. Just like a recipe tells you, then the code tells Robbie how to move his arms, legs, and other parts to do the things. The more you learn about coding, the more you can teach the amazing thing. So this one, I'm going to take the first answer and copy, because this one allows us to share and copy. So I can, let me see if I can copy this one. I can copy It has allowed me to copy. And this is the first prompt. So I can also fine tune it again. If I'm not satisfied, I can ask it again to tell it. Now, instead of a kill, I can ask it direct. What is the relationship between coding and robotics in 100 words? So I update it. Let's see the other difference. What you can ask us. Let's see the difference of the two. So we are using this prompt and see. Now the answer is there. So they're saying coding and robotics are closely intertwined fields that bring machines to life. Coding, the process of creating instructions for computer, the way I talked earlier, serves as the brain of a robot, dictating its movements, actions, and responses. Robotics, on the other hand, provides the physical body for the code to interact with the world. Without coding, robots could be a mere inert structures, incapable of performing any tasks. Conversely, without the robotics, code could remain confined to digital realm, unable to manifest its capability in the physical world. I remember I said our approach as Robotics Society of Kenya in matter of education is what we call physical computing. Physical computing is physical computer science, where we are mixing something like a robot. And when we talk about a robot, remember a drone itself is a robot. So some of you may think that a drone is not a robot. So a drone is a robot. That's a good thing you have to remember. So when we talk about a robot, a drone is part of it and part of it. So our approach, and I've said even a good example of a robot is the ATM machine. I've talked about the traffic lights, the one which you are knowing. Forget about the robots which you know in the factory, the one which do industrial production and other things. So this is the kind of one, and you can see the way they are saying that a robot without coding is nothing, and coding without a robot it's nothing. We have gone further to say that the one which even we are interacting right now, the Bard, but the Google Bard itself is what? Itself is a robot. Now that's good. So I think I've answered the question for Mr. Wanjara on the same year, and let's see the capability of Bard, because it's capable of doing a lot of stuff. So let's ask it another thing. Even I wanted to ask it in Swahili. So this time, because Bard understands Swahili, I ask, nataka kujiuliza sasa habari ya Kenya leo, tuelezee sasa. Mimi kwa sababu Bard inaelewa Kiswahili, nitajiuliza habari ya Kenya leo, kwa vile hii inaweza tuelezea chochote, inaweza tengeneza mbona niache nione, kwa sababu nataka na kuelewa. Niulize kwa sababu najua inaelewa Kiswahili. Niache nione kwa sababu moja wao ya Swahili. Tuone kama itakubali. Tutakujua kama inaelewa. Yes, yaelewa Kiswahili. Sasa tuiulize tena swali lingine kwamba seme moja hesabu ya kuuliza hesabu ya moja ongeza tatu ni jibu gani? Jibu gani? Cha tuone kama itatuambia nini. Hii ni katika lugha ya Swahili. Yasema kwamba hana maelezo ya kuhusu mtu huyu kusaidia kwa ombi lake, lakini tunataka kujua kwamba kama ina vile inaweza tengeneza hesabu. Acha tujaribu tena kuiuliza, kwa sababu hii inaitwa prompt. Unaiuliza maswali alafu kama kabla hujarudi Kiswahili, kwa sababu Bard pia atakana kuunderstand hii ni lugha gani. Sasa nataka na kuuliza tena swali lingine nione. Niulize Nairobi ni wapi? Nairobi ni wapi? Ama Tuulize swali lingine tuone kama itajua Bungoma. Mfano, hii ni mfano. Bungoma ni wapi? Tuone kama yaelewa Kiswahili. Kwa hivyo turudi kwa Kimombo. Umepata majibu na imetuambia kwamba Bungoma ni mji wa kaunti katika mkoa wa Magharibi, iko takriban kilomita hii. Kuna Bumura Central na nini. Hiyo ni kwa sababu inajaribu, itabidi venye unaona unaielezea sasa. Lakini tumeona kitu ya kwanza inaelewa kwa Kiswahili. Haya, wacha sasa tufanye kitu kingine sasa. Tufanye sasa, watu wanakuwa na shida na mambo ya hesabu sasa. Wacha tuone vile tutafanya hesabu. Tuulize, sasa tutaiuliza kwamba tunataka ifunze mtoto wa miaka 10. To teach a young 10-year-old kid how to do multiplication. So you can ask it, you put the prompt and ask it how to teach, ama you use the steps to take and teach a 6-year-old a sum maths problem. Utakuona itafunza mtoto wa miaka 6. Can you teach a young kid of 6? Which steps are you going to take? With examples. Also, you can go back and refine. So let's see the steps it can take. So then from there you can also fine tune it and then ask it something. Because it's so maybe on a chat, then let's see if you can ask it again, because you can go back and ask it. Show examples. So we want to see we are going from simple to complex. So we want to give samples of what it can work on. Because we want to ask it from example, we want to ask it also a code, a script, a Python script to this example. Let's see what it gives us. And then when we're done with Bard, we'll go to ChatGPT and then see the differences between them. So still processing. So this is like a human brain, and we are chatting, because I've told you, look at, there's even a, so it has even repeated the same thing you are working, but now it has given examples. That's what I wanted. So if it has said, for example, if the problem is 2 + 3, what can you do? You have the kid count 2 toys. You're going to wait because of the internet connectivity. So they're saying, if you have, for example, if this is a math problem and we're teaching a 6-year-old kid, so what are you going to do? For example, it's saying, have 2 toys, then add 3 more toys. Then tell the kid to, then which other steps? Then after that one, you introduce which step? The plus simple. Then from there, you practice, you continue with the word problems, and you continue, and then you finish. So you can see the examples. So it can add for you. It can give you just an example, and this one is just a calculator. You can see here. So if, let's say, for example, we tell it again, because it can be also a calculator. Let's say 100 divide by 20. Let's see the answer. Okay, it is specimen. Then you can have another one. Let's have another chat, and I request you to give a code for a school website. Tell it prompt and give a code for a school website. Remember we talked about the website. It should include, now this is the issue of coding now, HTML, of course, CSS, and JavaScript. You know, these are kind of programs which allows one to come up with a dynamic website. So let's say you are a Arduino, you don't know how to have a code, you don't know how to design a website, and you want to ask it. For example, you're talking about coding. Let's give a good example. You're forgotten, you don't know how to type, you don't know how to generate a code for that one. So you can see it has given you a sample of HTML, CSS. I will scroll down. So it's able to give you a full code for creating a website. So you can see, remember we talked about using HTML on CodeCrab, yeah? But if you go to Bard, it can allow you to this one. So it's still loading. And remember we talked about this HTML code. These are the languages, the syntax which you're going to use for you to give it. And let's finish, and then I'll show you. This is of course, this is the HTML. Let's see the cascading. And yeah, you can see where we are now. Now it has the style. So I can even copy this code here and put it somewhere. I can even share it. So let me see if it can allow me to share it. Or maybe I can just copy it the way it is here. It can allow me to copy it to email, to export it. You see, it can give me all this. I can also even create a public link. That's what I'm done. And I've copied the link. I'll share it I'll just share it here so you can be interacting with it. So under the message here, I've shared it on the chat. So you can have for it from what it has done there. And let's ask it, okay, this one. Then I can ask it also, create a recipe for chapati. This is a new one. I can have a new chat. That's what. I can ask it even a song. I'll see the things it can do. So I'm asking it to create. This is a recipe for. I know people will love chapati. For chapati and hen, for example. I want it to create for me. I want to cook. I don't know how to cook, and I don't know what the items I need for cooking. For example, chapati is a favorite food for everyone. So it's giving me that one. So I want to show you what it can do. There are many things it can do. So see, it can code, it can give you that instruction. And also I'm going to ask it also, I'm going to give it sample questions, which, so let's finish this one first. And then of course, yeah, yes, you can see from it. It's saying me I have for chapati, 2.5 cups of all-purpose, I have 1 teaspoon salt, vegetable oil, 1 cup. Let me see how many chickens it recommends. Oh, 1 chicken, 1 table, 1 teaspoon, 1 cup chicken broth. Then instructions. So I can cook chapati from the instructions which I'm given here. And also I'm going to share this. So those who want to create chapati and drive chapati, and this one you can use the instructions which are here with your own chapati. I see that. So I'm going to also to share this. And I'm also going to ask it to compose a song, a favorite song. So you can interact with it. So I'm going to ask it again. from a new chat. Compose which song for a song for let's say a lullaby for kids, but let me say a song. Compose a song to make a 6-year-old kid sleep, for example. So I've told you to compose a song because for a 6-year-old kid to sleep. So you can see it is doing all this for me, and I'm doing some, the basics, but I'm also going to, yes, you can see I have a song here. If you know how to sing, there's a song here. It has given me all the chorus, the songs. I can sing, and I can even fine tune it, so it can get a song here. And now let me ask it again. Another thing. Let me ask it to write a brief history of Kenya. Write a brief history of Kenya. Let me see what it does first. So if, for example, you are in a language class and you are being asked to write a brief history of Kenya, this is what it gives you. So it can give you, if you're an historian student or somebody who's interested in Kenya up to the present time, it will give you everything up to now. So that's a brief history. And then you can also go back to the other subjects. Let's say the other sciences. I can ask it to give a sample of a chemical equation. Give a sample of a balanced chemical equation. So it's going to work on this also. Let's see what it gives. So those who are interested in chemistry is yes. So you can see an sample of a chemical equation there, and it's going to work on that. So I'm not good in chemistry, but those who have done this, they can tell us if is that the right thing. You can see this is the right thing. Yeah, this is an example, but I can see this thing how you can combine reaction of magnesium and the oxygen. What does it produce? So I know those who have done chemistry, if they are getting on that. And not only that one, we can also add it even in computer. You can ask it to get in computer. Asked it, get 2's complement of, let's say, 50 and 78 in binary. Let's see what it can do here. Or I can advise that the other way around. So if you have any comments, you can just add on the comment section. If you have any question, you can add. You can ask us a question. We can answer on that. So it has given us 2's complement of 50, 78 in binary form. So I've used it. So in short, you see, we have done everything we want. We can do code. We can ask it for the recipe for full. We can ask it for compose for us a song. We can tell it to create it for a chemical. You see, so it is called a general purpose. And you see, unlike the other parts for the Google search, which of course will bring us a lot of links. This one gives us specifically what you need. Maybe you could ask yourself, or you can use on the comment section and ask on the question which it can help you. But this one can do all this. And even if you are a banker, for example, you want to do something calculation and ask it create assemble, let's say, a balance sheet for a small company. So let's see what it does here. If it can create a sample bar sheet for a small company. Let's see what it can do for us. Then we do the last one, and then we come to our end of the. So if you have, for example, you're in accounts and you wanted to do something like for you, you wanted to create for you a sample. Yes, that's a good example. And remember, these tools are free. Yes, you can see. I know those who have done accounts know this one. It has given you the assets, even it has given you the current assets and non-current assets. I don't know if it's okay. Then let's see if they have liabilities. The liabilities are there. Total long-term liabilities, owner's equity. This one, and but it just said also. Remember, and that's the caveat. It's saying, please note that this is not a substitute for professional accounting advice. If you have any question about your specific business, you should consult with your qualified accountant. Yes, that is what it's telling you. You should go and add to a qualified person. And it's not only this one. You can even put it for medical, but I don't want to use medical here because it's good to go to a doctor. But you can use something for a lawyer. Let's say, let's ask it for. Let's ask it to prepare a simple defense for a civil case involving finances for legal defense. Yeah. Okay, I'm not a lawyer, but I want to see if I can ask it for defense to help me defend myself. If I have a legal case, if I have a civil case, for example, and I want to use this tool to help me try and see if this is now the law I'm asking it. Let me see what it's asking me to prepare my defense. I'm saying this is not a substitute. I don't know if the lawyers are following this and know that this is the case. There's some of terms which, of course, I'm not familiar, but I can see. Giving me some options, even negotiating a settlement. I can go to trial. It's giving me. So it's asking me to hire an attorney to answer questions, be honest and cooperative. Yeah. So up to here, I don't think that you see there's nothing it cannot do. For example, the kind of the things you ask me yourself, it cannot do. So this is Google, but this is a company. Of course, they are using what we call generative AI. They are pre-trained to work on this, but this is from the Google company. Now let's use the most famous one, ChatGPT, and then ask it some few questions, and then we will, of course, wrap up on what we are doing. So I think I will close the and use chat. So what is remaining is to go to ChatGPT, and then from there we'll wrap up on our this session. So next, so let's go to StreamYard, and you will allow also me to present. This is of course I'm going to share my screen. So the idea is the same. You come here to Google search. Of course, they say ChatGPT has also an hub. You can download in the Play Store or in the App Store. Google Play Store, you can download it. Or they are also found in. You can download them in the Play Store. So you type ChatGPT already. It has been prompted to come in. So if you are the first user, it will force you to sign in. Let me see if it's coming in. So there's the option of signing up and starting up. So me already have an account with it. So I'll try to log in and see if it can allow me to log in. To give me option of continuing with Microsoft, with Google, with Apple. It gives you all those options. So I'm using the option of continue with Google. So my account is here. You can have many accounts to use. And you can now see the interface between the two of them. Oops, let me see if it's going to come in. Yeah, we are lucky. And we want to see a sample. Of course, there's many options. What we are using here is the ChatGPT 3.5. But as you are aware, we have an advanced format, which is ChatGPT, which is 4. So that's why they're asking you. Of course, I've agreed. And yeah, just let's go. This is what I've been creating. It can give you, the last time I was asking it with assistant with my visa, scholarship and something like that. So I can ask it, for example, a sample question I can ask it is also code. Let me just ask it a code for using Python. Let's ask it I'll give it a script. So ask it to write and then Python script, of course. Script to help construct a symbol calculator. Of course, when we talk about symbol calculator, we are talking about what? Symbol arithmetic, addition, subtraction, and other things. So you have to use ChatGPT to give us a simple code, assuming you are new in coding, and you see it has given me already a code, so I don't even now need to bother very much, because already I can copy this code and just paste it in they told me copy and paste this code into a Python script or interactive to run the calculator. Prompt the user to choose an operator and then text 2 numbers. So that's a good example. I know this scrolling. Yes. So you can see the rules of the year. Remember when we talked about Python. This is now the functions which have been made. Define. Def means in Python we are defining a function. This is the functions now. Add, subtract, multiply. So you can use those 4, and those the basic arithmetic conditions which you can use. So you can do, if you didn't know how to code in Python, for example, which is a text language, you can query ChatGPT to give you such kind of simple instruction. I think all other things I've done on the other part, because they also do the similar thing, and they have also operated there. They also do similar thing. I don't think there's nothing which I've not tested, because which you think like it could be challenging. I don't know if there's anything I've forgotten. But I know I want you to, because you have seen the site, I want you to be more creative. Just work with this. Try to run and see what it can do. But we said one of the rules here is what? One of the rules is for you is to know how to prompt this one, and that is the most important thing. Otherwise, let me just give another 2 rings here. And these are for the teachers. From here, this is where you prompt it, so you can have a lot of stuff. So because of policy, let's talk about policy. And in this case, I'm going to talk about teach AI. I'm going to just give a site. Schools, and not only schools, institutions, we need a policy on AI. How to work on safety, the safety networks of AI. That is where not actually where the challenge is. It is how best way to have a nice policy on. So this is the link here. You type teach AI here. So this is the link here. It's called teach AI. Is outside, which is giving a policy on how you can empower educators to teach with and about AI. So it has there's the guidance toolkit, there's community, there's also webinars which we have been working. So the kit is you can also visit the tool if you want. You can see the team which is involved in creating this one. There's code, there's ICT, and this one. So there's this the guidance kit is here. So for example, I think is a Google Doc. If you can go and have all those policies. That these are for kids. How you can use, for example, the one you are using ChatGPT and Bard. What is the policy? So you can see the principles which are here. I'm not going to go on this. It has everything for you. You can look at the principles. You can download them. You can see the potential of AI in education, for example. What we have been working here: assessment, tutoring, personalized creativity, operational. What we have been working here. So this is the future. And then also it's working on what? The potential risks of AI in education. We are not saying that AI is 100%. So these are the types of what? Risks and the types of AI being used in school. Generative AI, predictive AI, other users of AI, what to learn about AI, how to use the toolkit, and other things. And a framework, how you can use it in your school. So this one you can have it and create it so that it can work in your school. So let's finish with the Raspberry Pi Foundation and Google DeepMind. They are talking about AI. So I will search on that, and then DeepMind and Google DeepMind. AI. So let's see if it can bring it. Yes. So it's called your experience. So let me share also. So if you type this one, the Raspberry Pi Foundation and the Google DeepMind AI. So it's giving you this one. You experience AI with this Raspberry Pi Foundation and DeepMind. And the good thing about this one, this is also for kids. You can also work on kids up to 19. I think they are from 13 to 19. And we have also options. The itself where you can experience, you can experiment. Of course, there's a set of sources where you can work on. There's also teachers. There's the lessons, so you can explore the lessons which are here. So this is something you can do at your own pace. You can also have a video which is around that one, and you also have to understand how AI and machine learning here. There's also teachers. You can online course to machine learning and AI on teachers. So you can work on this one on view, and there's another challenge also which is coming. This will also involve schools in globally, but this is a first which is worthwhile for you to visit. Let me see if you can play this video, and I think this will be the last one.
What is artificial intelligence? With the rapid advances in AI and machine learning, it's incredibly important that young people understand how this technology is affecting their lives now and the role that AI applications will play in their future. The Raspberry Pi Foundation and DeepMind have partnered to create everything you need to learn about this exciting, cutting-edge technology. Enable your learners to understand what AI is and investigate a variety of applications through practical activities, to think critically about the societal impact of this technology on their lives and future careers, and explore ethical considerations through classroom discussions of real-world context. These lessons have everything you need to inspire young people through the power of AI. Lesson plans, presentation slides, educational videos, and worksheets, all for free. Sign up now at rpf.io/experienceai.
Thank you so much on this. So you see all these resources, and that's something which, of course, we want to emphasize. Most of these resources, they are being offered free, and as you can see on the online, they're saying, so you don't, I've given the links, you can just take it to your time when you are free, and then take it. So as I can see from there's nothing on the chat, and I think it has been a long session for us, but I think we have tried to cover each and everything which we wanted to cover as much we wanted to do in person. So I think this one will be our last event this year, unless maybe there'll be another, but I think this is one of the last events. If you can have one event, just it won't be very much in detail like this one. But I think from next year we're going to do a series of monthly sessions, which will incorporate all these skills. We do physical computing, the way you said that it's one of our tenets. We do chess education there. We also do AI. We also go to even machine learning there, and we'll be using these courses here for. But our approach is that we work with kids. That's the best method. Let's work with the kids and they learn as they go. But this is the skills which and every one of you can just come on forum. So thank you so much for those who have had the time to watch this one and then maybe contribute. And the most important thing one can do is that to share. You can subscribe, and you can also like the videos there, and also you can share to your colleagues and friends and ask them. As much as I know it's the video has been so lengthy, I agree with that. But the thing is that you can even forward. You check the session which you want, because we have tried too much to cover this one. So thank you so much from here. We are so happy. Hope to see you next time. Bye.